Lesson 5, Effective Value and Circuit Elements. Section 5.1, Effective Value. This is an extract of the voltages and frequencies of electric power distribution lines around the world. In Japan, 100 volts and 200 volts are used. The frequency is 50 Hz in the eastern part of Japan, including Tokyo and Yokohama, and 60 Hz in the western part of Japan including Nagoya, Kyoto, and Osaka. The voltages in this list are effective values. V is a sinusoidal voltage, and it is expressed as V equals Vm sin omega t, where Vm is the amplitude. The effective value Ve of a sinusoidal voltage is given by Vm over square root 2. An uppercase character is used to denote an effective value. By replacing the amplitude Vm with the effective value Ve, the sinusoidal voltage V is expressed as V equals square root 2 Ve sin omega t. In Japan, the effective values are Ve equals 100 volts and 200 volts, with their corresponding amplitudes Vm equals 141 volts and 283 volts respectively. Let me introduce the definition of the effective value of AC voltage. In the top figure, an AC voltage V is applied to a resistor R. In the bottom figure, a DC voltage VDC is applied to a resistor R. Both AC and DC voltages heat the resistors. If the heating effects are the same, then the DC voltage VDC is defined as the effective value. VDC is denoted by VE. The heating effect is equal to the average power consumed by the resistor. It is denoted by PAVE. PAVE equals 1 over T, times the definite integral of P from 0 to T, where P is the instantaneous power, and the uppercase character T is the period. The power P is given by P equals V times I. The current I flowing into the resistor R is, by Ohm's law, V over R. Thus, the power V times I, can be expressed as V squared over R. V is an AC voltage given as V equals Vm sin omega t, where Vm is the amplitude. By applying the trigonometric double angle formula, that is sine squared theta equals 1 minus cosine 2 theta, over 2, the definite integration can be performed. PAVE is derived as Vm squared over 2R. The heating effect of the DC voltage is equal to the power consumed by the resistor, and it is denoted by PDC. PDC equals VDC times IDC. Since the current IDC equals VDC over R, PDC is derived as VDC squared over R. The DC voltage VDC, which makes the heating effects the same, is obtained as VDC equals Vm over square root 2. Thus, the effective value of AC voltage VE equals Vm over square root 2. The effective value is also known as the RMS value. RMS stands for root mean square. Let's see why it is called the RMS value. Assume that a DC voltage VDC is equal to an effective value VE. VDC equals root RPDC. By definition, root RVDC equals root RPAVE. By substituting PAVE with this equation, VE becomes equal to the square root of 1 over T times the definite integral of V squared from 0 to T. This is the square root of the mean of the squared values, or root mean square, RMS for short. Exercise 5.1. This is your homework. An AC current is expressed as I equals Im sine omega t, where Im is the amplitude. Show that the effective value of the AC current IE equals Im over square root 2. The effective value of an AC current is defined as the DC current that gives the same heating effect as the AC current. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.